CI pipeline failed with merge conflicts on every PR. The team spent hours resolving the same conflicts. What broke? A junior dev had rebased a shared feature branch. Let's break down Interactive Rebase. Squash, reword, edit, and reorder commits, how it works, and the exact mistake behind that failure. Interactive Rebase lets you rewrite commit history by squashing, rewording, editing, or reordering commits. It's the power tool for cleaning up messy local branches before merging. Every developer makes mistakes. You commit a typo, then fix it. Before you know it, your branch looks like a Jackson Pollock painting. Interactive Rebase lets you clean up before anyone sees it. Run Git Rebase iHeadEnd to interactively rebase the last n commits. In the editor, change pick to squash, reword, edit, or reorder lines. Save and exit to apply changes. Here's a simulation of a messy branch with 4 commits. After running Interactive Rebase, we squash the last 3 into the first and reword it. The result is 1 clean commit. Squashing combines multiple commits into one. Use it when you have a series of fix commits that should be part of the original commit. The key: squash only commits that are conceptually the same change. Here's a concrete example. We have 3 commits for one feature. After squashing the last 2 into the first, we get a single commit with a clear message. Rewording lets you change the message of any commit without altering its content. Use it when you realize a message is misleading or when you want to follow a convention. Here's how to reword commits. Change pick to reword on the commits you want to edit, then write the new message when prompted. Editing a commit pauses the rebase at that commit, letting you amend its content. Use it when you need to split a commit into smaller ones or when you realize a commit includes changes that belong elsewhere. Here's how to split a commit. Mark it as edit, then reset to the previous commit, stage and commit each part separately, then continue the rebase. Sometimes commits are in the wrong order. Reordering lets you rearrange commits to make logical sense, but reorder only if the commits are independent. If commit B depends on changes in commit A, moving B before A will cause conflicts. Here's how to reorder commits. Simply reorder the lines in the editor. Git will apply patches in the new order. If conflicts occur, resolve them and continue. Interactive Rebase is not for every situation. Never use it on commits that have been pushed to a shared branch. Also avoid it on commits that are tagged. For simple message changes on the last commit, Git commit amend is faster. And if you're on a deadline, don't clean up history, just merge and move on. This is the same issue we highlighted at the start. Here's exactly why that happened. A junior dev ran Interactive Rebase on a shared feature branch that 3 other developers had based their work on. The rebase rewrote all commit SHAs, so Git saw entirely new histories. Every time someone tried to merge, conflicts appeared. The team spent hours resolving the same conflicts repeatedly. The root cause was rebasing a shared feature branch that other developers had based their work on, which rewrote commit SHAs and caused history conflicts. The fix established a rule to never rebase shared branches and to use force with lease when force pushing. The fix was simple: establish a rule that Interactive Rebase is a local-only operation. Once you push, the history is public. If you must rewrite, coordinate with the team and use force with lease. This resolved the incident and prevents recurrence. Never Interactive Rebase a branch that has been pushed to a shared remote. You'll rewrite commit SHAs, causing chaos for anyone who based work on the old history. This is the exact mistake from the incident. Running Interactive Rebase on a shared branch rewrites commit SHAs, causing chaos for anyone who based work on the old history. Always keep rebase local. Rewording a commit that's already in a shared branch will change its SHA. This breaks any tags or references to that commit. Only reword commits that are local or in a feature branch you control. If you forget to stage changes after editing, Git will treat the commit as empty and abort. Always run Git status after editing to ensure you have staged changes before continuing. If you make a mistake during an Interactive Rebase, run Git Rebase abort to return to the original branch state. This uses ORIG head to reset, so you lose no work. Interactive Rebase rewrites commit SHAs. which invalidates any GPG signatures on those commits. If your project requires signed commits, you must re-sign them after rebasing using git commit amend no-edit s for each rewritten commit. The article mentions auto-squash, but doesn't show the workflow. Create a fixup commit with git commit fixup equals commit, and then rebase with auto-squash to automatically squash it into the target commit. Here's how to diagnose and fix common rebase issues. For conflicts, resolve them and continue. If you lose commits, use git reflog to find the pre-rebase state. If force push is rejected, fetch and rebase first, then use force with lease. Let's run through some common interview questions. How does Rebase handle merge commits? By default, drops them. Use Rebase merges to keep. When to use Rebase versus git merge squash. Rebase for curated history on branch, merge squash for squash on merge. What happens if you reorder conflicting commits? Git pauses for conflict resolution. And a few frequently asked questions. How to squash last 3 commits? Git rebase I head -3, change pick to squash. Difference between squash and fixup. Squash prompts for message, fixup discards message. How to undo a rebase? Use git reflog and git reset hard before push. To recap, squash related commits, reword to fix messages, edit to split commits, reorder to tell a better story. And always remember, never rebase a shared branch. Use git reflog before risky operations. If you're on a deadline, skip the cleanup and ship first. Ready to go deeper? Up next, Git bisect. Find the commit that introduced a bug, then Git submodules. Managing nested repositories, then Git internals, objects, trees, blobs, and the DAG. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.